Hey guys, somehow the other video did not have sound, so I'm going to just sort of talk over the video and let you know what's going on in case you can't quite tell just by watching. So here we go with our y equals x squared, and what I was talking about was finding the average value of that function y equals x squared. And so I was explaining, just to find the average of anything, of course, you just add up, the total amount of what you've got and divide by however many there are. So for something like this, we would add up the y values and divide by how many y values we have. So I picked, convenient ones from 0 to 5, and the y values, of course, would be, 0, 1, 4, 9, 16, and then 25. So if we wanted the average of just those 6 values, of course, we just add those up and divide by 6. So I'm just showing that real quick. And that would represent the average value of this function, or an approximation of the average value of this function from 0 to 5 using 6 data points. Of course, there are obviously more than 6 points on this curve from 0 to 5, and in the context of a function, you'd have an infinite number of points, which is a little bit more difficult to average. And so I'm sort of just showing that obviously there are a lot of points. So the average value that we just got, you can sort of think of that as like an average height, if you will. Remember how we, were making the rectangles, and we would draw in the different rectangles with different bases and heights and whatnot. So this average value could be like an average height at a particular, for a particular rectangle. So that's what I'm showing here. I didn't, obviously, if I had graph paper, I would have done a little better job approximating, but if we use that average height, we could draw a rectangle that represents the area with a base from 0 to 5 and a height of, approximately the 9.2 or whatever it was. And that area should be the same as the area under the curve, assuming the average height, is accurate. So again, ours is just an approximation, but it'd be reasonably close. If we were to actually calculate that area right now with a height of 9 and a base of 5, it'd be 45. And we know the area under x squared, was, I think it was like 41 2/3 or whatever it was when we did it old school. So that would get us an accurate value. So area obviously is just base times height, like it always has been. That hasn't changed. So if I want to solve for the height, then I can just divide both sides by base and get height equals area over base. And we know how to find area, right, using our integral. And we know how to find base. That's just b minus a. And then, of course, the height would represent our average height, which is our average value that we've been talking about. Okay, so here comes a little summary. The average height is going to be the area divided by base. So 1 over b minus a is like dividing by base. And our area, of course, is our integral. And that is essentially our average value. Okay, the area under the curve will be the area of that rectangle with a height that represents the average height. So if I want to actually calculate it for this particular example, I know 9.2 is not going to be accurate because I only use 6 points. But if I calculate it out the right way, where all the points are taken into consideration, I can actually calculate it out the proper way. And that's what I'm about to show here. Okay, so 1 over 5 essentially, right? b minus a is 5. Calculate out the integral, which we've done a million times. So x cubed over 3, evaluated from 0 to 5. Substitute in and then simplify. And that will give us the exact average height for that rectangle that has the same area as under our curve. So it looks like, what, 25/3? So about 8 1/3. Or actually exactly 8 1/3. So if I were to make that height 8 1/3, then my rectangle would have the exact same area as the area under the curve, because area is just base times height. So here I'm just showing what that actual average, that actual area is, which we already know, right? 41 2/3. We've done that before for x squared. Okay. I don't remember what I was saying here, to be perfectly honest. I think I was just repeating myself. So you can just rewind if you need to. So average value is 1 over b minus a times the integral from a to b of the function. Okay? Let me know if you have any questions. This should get you through pretty much any average value problem. Obviously, the integration can be more complicated. You know, it could involve any of the tricks we've learned so far. But essentially, this is just base times height. Right? Divide both sides by base, and there you go. You have your average height, your average value. Again, I think I'm just repeating myself like over and over and over again. So if you need to, rewind, ask questions, post, whatever. I'll talk to you later.